ওয়ালাইকুম, শোনা যাচ্ছে?
Yes, sir.
আসসালামু আলাইকুম, শোনা যাচ্ছে?
Yes, sir.
ডক্টর কর্মকার কেমন আছেন?
ঠিক আছে। মোটামুটি আর কি। আপনি কেমন আছেন?
আছি আলহামদুলিল্লাহ।
ভালো।
জি।
হ্যাঁ, দেখি তো মাঝে মাঝে টেলিভিশনে দেখি আর কি। ভালোই লাগে দেখলে কথাবার্তা শুনে। থ্যাংক ইউ।
ফিজিক্যালি তো অনেকদিন দেখা হয় না।
হ্যাঁ, অনেকদিন দেখা হয় না। আসলে তো আপনার করোনা at the same time আমারও কিছুটা অসুস্থতা ছিল আর কি।
ও আচ্ছা।
এই কারণে।
Okay, sir. Thank you for joining the final session, closing session of ICMCS 2021. So this session has four papers in it, and the session will be chaired by Honorable Professor Dr. Dewan Abdul Qadir, sir, and also co-chaired by Dr. Shomarendra Karmakar, sir. So I am now handing over the session to both of you, Qadir, sir and Karmakar, sir. Thank you.
Thank you, sir.
Thank you very much, bro.
সাউন্ড শোনা যাচ্ছে না। সাউন্ড শোনা যাচ্ছে না।
Hello.
হ্যালো।
My chairman.
Yeah.
Yeah.
Welcome
Okay.
all participants to this technical. I mean the last session, last technical session. I welcome also the co-chair, Dr. Shomarendra Karmakar.
Dr. Diyakada, thank you
And
very much.
if I am lost, then you will take the chair.
Definitely, I will take the chair, and also if
Okay.
I am lost, you take the
Karmakar,
chair.
you are muted, Karmakar.
No, I'm not muted.
Ah.
I'm not muted. I don't know
You're
why.
not muted. Okay. Yeah, it's good now.
Thank you.
So let us start this session. I would request Professor AKM Saiful Islam to present his paper on changes in climatic impact drivers over South Asian region based on IPCC assessment report AR6. So Saiful Islam, please.
Thank you, Honorable Chair, Professor Abdul Qadir, and also Honorable Co-Chair, Dr. Shomarendra Karmakar. I'm just starting my screen share to start my presentation. So I think I'm audible, and you can see the slide, right? Okay. My slides are visible, right?
Yes, visible.
Okay. Thank you. So the topic of today's presentation, I'll talk about the next 20 minutes about the changes in climatic impact driver over the South Asian region based on the IPCC 6th assessment report. And I'm working at the Institute of Water and Flood Management, BUET, as a professor and also lead author of this 6th assessment report, working group 1. I contributed to this report, and so it will be very exciting to present the key findings, particularly over the South Asia and Bangladesh region. I will also focus on the findings on the globally, so that we can see what are the changes assessed in this report, and so that then I'll go for the regional scale. And this International Conference of Meteorology and Climate Science organized by the Dhaka University, I am appreciated to invite me to present these key findings of this report. First, we like to mention that recent changes in climate are widespread, rapid, intensified, and unprecedented in thousands of years. And these changes is caused by primarily human influence. And if you see the left side graph, you can see the observed warming is more than 2000 year, it was unprecedented. This is the year 2020. And if you go back to year 1, you can see that the warmest year record in the 1000 century, multi-century period is about 1 degree. But now we are crossing 1.1 degree. About the any record observed period, we crossing that level. So it was always below 0.5 degree, but now we are crossing 1.1 degree. If you consider why this happened, you can see that there are causes and just one second. Sorry. So if you have a look at what is the reason, you can see this graph shows if we simulate the climate model from 1850 to 2020, it was naturally and solar and volcanic activity. If we consider in the model, we can see that that is not able to capture the present observation that is in the black line. If we simulate with the greenhouse gas, that is able to capture this trend. So that means these changes of the warming or global warming actually caused by human activities. And this report also mentioned that over the 2 million years, the carbon dioxide concentration is highest. Sea level rise is fastest rate over the 3000 years. And Arctic sea ice area is the lowest level in last 1000 years. And the glacier retreat, the melting of glacier is unprecedented over 2000 years. So all these changes bring more catastrophe and it influences the extreme events. You can see that globally extreme heat become more frequent and intense. Heavy rainfall become more frequent and intense. Drought increasing in some regions. Fire weather, which is a condition of wind, temperature, and hot with and moisture condition, dry condition. This tree actually increasing the fire weather condition. You can see frequent wildfire, bushfire in many regions of the world. Ocean is also influenced by climate change. Ocean become more warm, acidifying and losing oxygen. So unless there is an immediate, rapid and large unless there is immediate, rapid and large scale reduction in greenhouse gas emissions, limiting warming to 1.5 degrees centigrade will be on reach. And this report shows that in next 2 decades, by 2040, all scenarios shows we are going to exceed 1.5 degrees centigrade, unless we are seriously reduce greenhouse gas emission. Currently, we are 1.1 degrees centigrade from the pre-industrial level. So if you consider that this is the level that we are here, and next 2 decades, we will cross 1.5 degree, considering all the different pathways from very low to very high scenarios. And this is the scenarios that shows that how carbon dioxide emission will be in the end of this century. And very high emission scenario shows that will be double by 2050, and some scenarios are double by end of the century. But these are the 2 scenarios, RCP 2.6 SSP1 and RCP 1.9 SSP1. These are low and very low pathway. Only these scenarios will be reducing drastically CO2 so that we can be below 2 degrees centigrade. So the future, the warming will be affect surface temperature will be increasing, and the more greenhouse gas emission in the atmosphere will cause more surface warming. Surface here means the land surface and ocean surface, and the amount of warming from comparing to today, the different scenario by the end of century is shown here. And if we have very high emission, the present scenarios that we are heading towards, that would lead to a more than 4 degrees centigrade. But if we do the emission cut as proposed by the Paris Agreement, the recent pathway, it shows that the maximum we can achieve is 2.4 degrees centigrade. So we are not still able to keep below 2 degrees centigrade global warming because there is still not much promise to cut the greenhouse gas, limit the greenhouse gas emission so that we can at least reach 2 degrees centigrade by the end of century. So all the promises so far still not able to meet the Paris Agreement. And what are the possible changes in the future? If you have a look that the changes are large in many regional regions in terms of temperature, precipitation, and soil moisture. Here you can see if we have 1 degree global warming, the world will be like that. There is a huge spatial variation, particularly Arctic region will have more warming than other region because of Arctic amplification. When ice is melting, it will absorb more, water will be more warm, water will absorb more energy, so that this region will be more warm compared to other area. And you can also see the land will be more warm than ocean if you consider 4 degree global warming scenario. And the more warming scenario will increase the global temperature more. And if it even 4 degrees centigrade, you can see there is a spatial variation. For the changes of the precipitation, there will be spatially varying situation because of the circulation pattern, as you know, varies with region to region. Particularly for the monsoon region, it will become more wet if you consider the 4 degrees centigrade, like Bangladesh, India, Nepal. So it will have more precipitation, annual and summer precipitation. But other regions in the world, you can see some regions will be more dry and more drought is expected those regions. Considering the soil moisture, we often show the same pattern of precipitation, but this is the scenarios that monsoon region will be more soil moisture condition than other regions, but some of the area will be more dry because not that much of rainfall and evapotranspiration will be increased, so that area will be suffer from more drought condition. And what is actually happening if warming will increase? This is often a big puzzle for many people who are not from the scientific background, because they thought in a single day we can observe 5 to 10 degree variation of temperature. But I like to make it clear from this assessment report, they shows that how the global atmosphere and Earth will actually respond to increase of the global warming. Considering that, even though if we consider 1.5 degrees centigrade, the global variation, it will be from 1.5 to 1.9 degrees centigrade. Similarly, for 4 degree global warming, it will go up to 5.6 degrees. Considering the drought situation, today we already observed that 2 times more drought conditions that occur in once in a 10 year, once in a decade, that has increasing twice. In the future, 4 degree warming, those drought occurring frequency will be increased 5.1 times, the same drought that has been in the pre-industrial period. Similarly, for the precipitation, the higher global warming scenario shows that the wettest day in a decade will be 2.8 times more in the future. For the snow cover, it will be reduced 25% area. For the tropical cyclone, the proportion of the high intense tropical cyclone will be 30% more. That means category 3 to 5 category cyclone will be more. Not the total cyclone will increase, but the proportion of the heavy intense cyclone will be 30% increase with global warming, which is a very alarming for a region like Bangladesh. Because we are prone to many cyclones and we are very flat topography and we are in the coastal region. So more category, higher category cyclone will be influencing our coastal region. And some consequences like sea level rise, it will not stop by the end of this century, it will continue. This is equivalent 2000 year commitment of sea level rise. You can see 1.5 degree, even we stop emission of greenhouse gas, it will continue by this after this century, and it will be rise up to 3 meters. And for 10,000 year, it will be continue to rise up to 7 meters. So it is not going to stop here. So that's a very worried process, because we can be protected and reduce the greenhouse gas now, but some of the process have long-term consequences. Similarly, global temperature change will be increasing. With all scenario shows that it will be increasing in many regions, and we can see widespread, rapid, and intensify impact on the world. We can see also Arctic sea ice area will be reduced in the future, and we already have observed that Arctic sea ice is increasing, and there is a probability that the summer ice-free Arctic will be occur at least once by 2050. And surface ocean pH, which is acidity or alkaline measurement, if it is more than 5.5, so or more than 6.5, then it is alkaline. Less than 5.5, it is acidic. But in the as CO2 is absorbing in the by the ocean, we can see ocean become more and more acidified, and the higher scenery become more increasing acidity in the future. And we can also see global mean sea level changes that will be increasing. The more greenhouse gas emission, the sea level will go beyond 1 meter by the end of this century. And as I show in the previous figure, it could even go beyond that because this process have long-term consequences. It will not stop in 2100. And some of the process in these dotted lines show this is very low likelihood, high impact storyline, because we don't know how ice sheet instability process will happen. If sudden collapse can cause very high level of sea level rise. This assessment report shows that more of this low likelihood, high impact event have more chances if greenhouse gas increasing more in the future. And it is also, this report shows that it is indisputable that human activity are causing climate change, making extreme climate events, including heat wave, heavy rainfall, droughts, more frequent and more severe. And for the total annual increasing of warming, actually caused by a counterbalance of two things. One is increasing greenhouse gas, and also the decreasing by aerosol concentration. These are aerosol concentration. Otherwise, we would have even more than 1.5 degree warming by now. Since the aerosol concentration is doing cooling, so a total warming is now 1.1 degrees centigrade. And not only the CO2, but also methane is a second largest contributor. This column, this is carbon dioxide, this is CO2, and other nitrous oxide and other halogenic gases are contributed. And these are the cooling effect by sulfur dioxide and other. But in future, when air will be more pollution free, we can see more warming actually, because this will be reduced and that will add in the greenhouse gas induced global warming. So in the future, we might see additional warming because of the cleaning environment. And you can see that this is the graph in the interactive atlas. This report shows where you can see that these regions will be extreme hot extreme will be increased, and South Asia, you can see this region hot extreme will be increased, and for heavy precipitation, South Asia will be increased. For the agriculture meteorological reason, fortunately, our area have no agreement of the increase, but some of the area in the Asia and Europe has more increasing drought condition. And these are the climatic impact driver with different climate condition. It could be a mean changes, it could be a trend, or it could be extreme. This report identified 33 climatic impact driver, and you can see that changes of the different regions is listed for all regions of the world. So I would request you to have a look of the changes of different regions of this report. And the primary changes occur in the water cycle because of the warmer temperature. Atmosphere hold more water, it more faster evapotranspiration, heavier precipitation, and intensified dry season drought. So that's why we'll see the more extremes in which are water related disaster. And in the interactive atlas, you can change the reference baseline condition and climatic impact driver over your region. You can see the changes in the future. And this is the website where if any students or academia can go and have a look of the changes in their regions. So I'm about to finish a couple of more slides. Climate change is already affecting every regions of the earth in multiple ways. Changes we experience will increase further warming, and there is no going back from some changes like ice sheet melting, like sea level rises in the climate system. So these are the changes we will observe even we stop our additional greenhouse gas emission. And some changes would be slowed if we limit the greenhouse gas, and others could be stopped, but some of the changes will be continued. So there is no going back from those kind of changes. And limiting global warming, strong, rapid, and sustainable reduction of carbon dioxide, methane, other greenhouse gases are necessary. This is not only reduce the consequence climate, but also improve the air quality. And this report also shows there is a near relationship between the cumulative greenhouse gas emission and temperature change. So the additional CO2 in the atmosphere will increase the warming. So, and another interesting thing is the more increase of the greenhouse gas, that could cause changes of the land and ocean absorption of greenhouse gas. Currently, 70% of this CO2 is absorbed by land and ocean, and atmosphere absorbs 30%. But if warming scenarios, if it's more warm in the future, then this absorption will be land ocean by only 38%, but all rest of them will be in the atmosphere. So these are the different scenario how it changes. A few slides before end how South Asia is going to be.
You have one more minute, Professor Saiful.
Yes, yeah. So in the South Asia, the mean temperature will be clearly extreme heat wave will be increasing. Marine heat will continue. Fire weather will lengthen, intensify, and precipitation will increase. Many countries, including Bangladesh, and surface wind speed have decreased, but it will continue to decrease in central and north part of Asia. Glaciers are declining and permafrost is thawing. Glacier runoff Asian high mountain will increase, and relative sea level rise will be increased, particularly it will increase for Bangladesh. And these are the scenarios since there is not much time, but you can draw this kind of figure, how temperature will be changed in South Asia and how precipitation and seasonal cycle will increase. So these I draw from the interactive atlas, so that any reason you can draw the rainfall change, extreme rainfall change, it's a 1 day maximum precipitation total, those are increasing for our region, and sea level rise, wind will be also increasing. That's it. And in Bangladesh region, I leave it like that. This is the last slide. So this is what we are going to expect: the flash flood, drought condition, urban flood, salinity, sea level rise, and cyclonic storm surge. We are going to impact our country. So I stop here. Thank you.
Thank you very much for your very nice presentation, Professor Saiful Islam. Now I will request Mr. Rabiul Awal to give his presentation on the relationship between the atmospheric heat transport and monsoonal precipitation variability.
Hello, sir. Do you hear me?
Yes, please.
Okay.
Go ahead.
So, okay, first I need to share, I think I need to share my screen, right? Can anyone guide me how to share my screen? Sorry. Okay, I got it, I think. Okay.
You got it?
Yeah, I think. Okay.
Yes. Yes.
Okay, you see my screen,
Yes,
right?
yes. Yeah.
Okay. presentation mode. Then, okay, yeah. Okay, good afternoon, everyone. So the title of the presentation is the relationship between atmospheric heat transport and monsoonal precipitation variability. So during this study, I have been supervised by distinguished Professor Andy Turner and Professor David Ferreira. Okay, so northward atmospheric energy flux is the vertical integration of northward latent energy, internal energy, and geopotential energy. The total integration of northward atmospheric energy flux is termed as atmospheric heat transport. Atmospheric heat transport crossing the equator is named as CEAHT, and I will be using this term as CEAHT. So Hadley circulation, we know that the overturning circulation has some features like ascending air near the equator and descending air near the subtropics, and low pressure belt of converging trade winds is known as the intertropical convergence zones, or ITCZ, which has, maximum precipitation occurs often close to the ITCZ or along the ITCZ. So the scientific questions are: how do CEHT variation influences the ITCZ position on a regional scale? How do CEHT and monsoonal precipitation covary? And how do CEHT changes stream function? CEHT variations shift the rising branch of Hadley circulation. That's our hypothesis, and it's been demonstrated by the left side figure. And here we can see due to the variation of CEHT, the variation in ascending branch is shown by the red and green arrow, and the subsidence branch is shown by the cyan color arrow. And as a result of the shift of rising branch of Hadley circulation, the ITCZ would shift, which has been shown by the right side figure. On global scale, more southward CEHT, cross-equatorial atmospheric heat transport, means more northward the ITCZ would be, which has been studied by lots of distinguished professors in 2013, 12, and 14. Okay, so for my study purpose, for the analysis of atmospheric heat transport, I have used ECMWF reanalysis era 5 dataset for the period 1979 to 2020. And for the analysis of precipitation, I used GPCP monthly mean dataset for the same period. Northward atmospheric energy flux is given by, is calculated using the following equation shown here, and the first term represent the internal energy, the second term represent the latent energy, and the third term represent geopotential energy. And the northward atmospheric heat transport is calculated by the below or bottom equation you can see here. Okay, the annual cycle of cross-equatorial atmospheric heat transport is shown by the top figure, where the blue bar represents the mean value, monthly mean value, and the box plot represents the minimum value, and then first quartile, and then median, third quartile, and maximum value. And these white blobs represents the outliers. Okay, so we can see here the maximum northward transport occurs in the month January, and maximum southward transport occurs in the month July, and the mean northward transport is 0.6 petawatt, and mean southward transport is minus 0.9 petawatt, and the annual mean transport is minus 0.3 petawatt. The annual mean cross-equatorial atmosphere, annual mean atmospheric heat transport is shown by the bottom figure, where the mean represents by the red color curve, and mean plus standard deviation by green color curve, blue color curve, and green color curve represents the mean minus standard deviation. And we can see again here the cross-equatorial atmospheric heat transport is negative. That means it's southward, and the standard deviation peaks at around 40° north. So seasonal cycle, the left figure represents the seasonal cycle of northward atmospheric heat transport, and we can see that during JJA, CEHT peaks and it's southward, whereas the northward CEHT peaks in DJF, and northward and southward atmospheric heat transport peaks located around 40° north and 40° south respectively. And the right side figure represents the seasonal standard deviation of northward atmospheric heat transport, and standard deviation in seasonal atmospheric heat transport is largest at 2° south in JJA, and the highest standard deviation in DJF is at 25° north. So the regression analysis between precipitation and cross-equatorial atmospheric heat transport is shown by the top figure, and the black lines represents mean precipitation during JJA. Color contours exhibit the slope of regression analysis. So here we can see that along the equator, it's positively correlated, and that means over the Pacific Ocean, the ITCZ would shift towards to the south from its main position, and we also can see the decrease of precipitation over Western Ghat and the southern flank of Himalaya, which implies that the Indian monsoon weakens due to strong cross-equatorial atmospheric heat transport. The precipitation over West African and North American monsoon domains get reduced, which is also visible from here. And the bottom figure represents the regression of cross-equatorial atmospheric heat transport with wind, and 850 hectopascal wind, and the precipitation. So the slope of regression by the vectors is regression of cross-equatorial atmospheric heat transport, and wind is represented by the vectors, and similarly the color represents the slope of regression between cross-equatorial atmospheric heat transport and precipitation. So we can also see here a strong positive CEHT is strongly correlated to a pattern consistent with a positive Indian Ocean dipole here over the Indian Ocean domain. Okay, so then we find out the correlation between cross-equatorial atmospheric heat transport and different monsoon domain, like American monsoon, West African monsoon, and then Indian monsoon. And we see that the Indian monsoon has correlation -0.72, and West African monsoon has correlation -0.51, and North American has -0.66. So this then we analyzed, regression analysis between cross-equatorial atmospheric heat transport and stream function is shown by this figure, and the black lines represents the stream functions, and the color contour represents the slope of regression. So the ascending branch and descending branch of the Hadley circulation is getting narrow, and the altitude of top layer gets reduced, return flow weakens on the surface level. So the conclusion, here we can see the enormously large cross-equatorial atmospheric heat transport shifts the ITCZ southward over the Pacific Ocean, and the relationship is complex outside of the Pacific Ocean domain during JJA. The rising and descending branch of Hadley circulation shrinks equatorward, or I should say, southward, and the altitude of the top layer get decreased. In boreal summer monsoon, the Indian, West African, and North American monsoon weakens with the increment of cross-equatorial atmospheric heat transport, and correlation coefficients are -0.7 to -0.51 and 0.66 respectively. And the future work will be like examining interannual variability and ANSO associated variability, and then conducting similar analysis of atmospheric heat transport using CMIP6 models and data set. So what we got that more cross-equatorial atmospheric heat transport implies that the rising branch is shifting towards the equator or to the south, and that means that implies that the peak ITCZ also shifts towards the south. So yeah, that's it.
Thank you, MD Rabiul Awal, for your very nice presentation. It gives a very good picture of the energy transport and monsoonal precipitation variability. And I hope that you will complete your research soon and we'll hear more from you. Thank you.
Okay.
And now I will invite.
Request Rabiul Awal to turn on his camera because I want to see him after a long
Yes.
time.
I didn't notice it.
Yes.
Yeah, I'm good, ma'am. How are you doing? I didn't notice it. Actually, I was thinking that maybe I'm visible. I did not notice it. That I mean, after finishing my talk, I was looking for myself.
Confident. Yeah, fantastic. Thank you, Rabiul.
Yeah, right.
It's nice to hear from you. Thank you, Rabiul. Take care.
Thank you, Rabiul. Now I will invite the Mr. Dr. M.K. Das to present his paper on climate extremes over Bangladesh, observed trends. Dr. Das, please.
Thank you, sir. Can you see my slide?
Yes.
Okay. Thank you, Honorable Chair and Co-Chair and distinguished audience. The topic is climate extreme over Bangladesh and observed trends. The main motivation of my study is in Bangladesh, regularly faces various extreme events. Those are flood, droughts, cyclones, heat waves, and many other extremes also available. But there is a knowledge gap between the average climate and climate extremes over the country. Society suffers from the loss in the natural disasters and thus more sensitive to know about the changes in the pattern of this disaster well ahead of their occurrence. When considered in a general sense, these disasters are essentially the extremes events which are part of the climate system. The main objectives of our study is to quantify trends, especially and temporarily both in the expert team on climate change detection and indices, well known as ETCCDI extremes temperature and precipitation indices over Bangladesh during 1981 to 2010. A summary of the changes in the study area and possible future implications of these changes for policymakers, various different sectors, especially water resource managers, major stakeholders, and donor agencies is also provided. The result of this study can pave the way for further investigation into future changes using results from the climate simulations. The outline of my study is introduction, data and methods, climate indices, results, discussions, and finally conclusions. In introduction, climate change, we know, is often defined as increase in mean global temperature as per Allen 2009 and Matthews et al. 2009 and Ruppers et al. 2011. Well, this is general way to identify the climate change. The impact of climate change is not directly evident from this indicator. One might argue that it is not climate change that does not harm, but the natural disaster that accompany it from which society suffers significant losses. Therefore, it is important to understand the potential future change in natural disasters, the extreme events of the climate system. In our study, the region in the right panel figure shows the Bangladesh neighborhood regions, and the triangle red color indicates the stations. Out of the 46 BMD stations, we have selected 35 stations which data is available. And one more important thing is that distinguish of the seasons. In various journals, it is found that many researchers differentiate the seasons every 3-month interval. But in South Asian region, it is not like that. So one very recent study done by Khatun and al., it is from the Bangladesh Meteorological Department. It is a very good reference for new researchers. So as per their finalization, the seasons are pre-monsoon, monsoon, post-monsoon, and winter. We all know better, but duration is important. And the 80% total rainfall receives during the monsoon seasons. And if Bangladesh is a subtropical country, the climate is moderately warm. The normal monthly maximum temperature ranges in January 24 degrees Celsius maximum, 16 degrees Celsius minimum on average. And in May, it is 35 degrees Celsius and 30 degrees Celsius. And in also the contour showing the precipitation average over the regions. So it indicates the northeastern regions is the highest, and second highest is the southeastern regions. Here we have selected indices, 27 indices, extreme climate indices. I already mentioned it is WM and WCLP defined. And these indices I will show in the table later. And calculation of indices have been done using Arclimadex and other art tools for the study. And of course, for the statistical method, we have used sand slope estimation, regression coefficient for the study, and Kendall tau estimation, robust estimation, which is of course a monotonic trend, and finally analyze the man-current trend test. Here we have shown up in the left table. It is all the stations, but some stations removed for the short series of data or the missing data, especially some significant extreme event happened in Sondip regions, especially 1991 cyclone. Other that time there is a data gap. So thus, due to those, we have removed those stations. And right table shows all the extreme temperature and precipitation indices. In the top one for the temperature and below one for the precipitation. But not all are in uses. Like for example, frost days, ice days, those are not important for our regions. So we have ignored those. Here is the results. We had shown the changes in temperature extreme across Bangladesh, mean frequency and extreme temperature. So first one is the annual and other fours for the seasonal. Individual parts are showing the average annually, while the dots are showing the spread of the individual stations. And there is a shaded zone which showed the confidence, 95% confidence interval. Here we are showing the mean and frequency of the extreme temperature. One for the warm and cold days, and for top one, and below one is the warm and cold nights. Solid state lines show the trend lines found from the sand slope estimations, and the 90th percentile indicates the warm nights division of the days, and 90th percentile of the days, and others indicator it is already mentioned in the table. And now the changes in temperature, mean and frequency of extreme temperature. Here is we are showing the probability distribution function, well known as the PDF, of the annual frequency of cold days and cold nights, warm days and warm nights over the Bangladesh for the 3 different decades. Those decades are 1981 to 90, and the mid one is the 91 to 2000, and final one is the 2001 to 2010. To detect the temporal changes, we divided the study, as I mentioned, 3 different decades. A systematic shift are observed in here, especially in the very recent decades. It is most prominent during the brownish one. Now the changes of extremes, a special distribution of hot temperature indices and some other indices we are showing here. It indicates which regions are much more sensitive, which are positively significant, which are negatively significant, and negative but not significant, negative but significant. So solid triangle showed the positive significant zones over the regions for different indices. And some region it's only for the very close to the coastal region, some only for the northeastern region. These are the select. These are the positively significant, and some regions showing the negative but not significant. These are the very close to the mid zone. It is Dhaka for nearby regions. Changes of extremes for the cold extreme or for the temperatures. Here also we are getting the information by analyzing the data, which zones are positively significant. It is only very limited zones, just northeastern two stations, Sylhet and Simangol, and the very close to the coastal zones, two zones only, and another is the near to the Ishordi. And negative but significant zones are in the very close to the coastals in the 40 and 10 percentile. Khulna, Khulna, and very close to the other zones are here showing. And the magnitudes we are studied individual station wise. Only bold showing the statistically significant, and the confidence is 95 percentiles. Here we have found some coastal zones are showing the 95% significant for the temperature, and also the northeastern zones, Sylhet and Simangol. Now, changes in cold extreme temperature, the unit here, the right panel here showing the unit of the trend of number of days per 100 days, red straight line, regression line, and shaded area, 95% confidence interval of the regression. It is showing that the negative regression line between warm days and cold days indices that both indicators show a warming trend, while warming days are increasing and cold days are comparatively decreasing as per the analysis. Now, changes in the precipitation. As of now, I have shown only for the temperature. Now, for the precipitation, first one for the annual and precipitation annually, and others for the different seasons. And bar showing the values for the stations, how it ranges for the precipitation, and orange for the positive anomaly, and blue for the negative anomaly. Dot indicates the individual stations value for the particular years. Now we are showing the changes in extreme precipitation indices for the different indices, how it is significant positively or negatively. For R100, it found that there is not that much positive or negative significant. Both are very close to the zero. R100 is not that much, but others showing that positive significant. For the R10, it is very close to the some very couple of stations, approximately 6 stations. But consecutive dry days, it indicates that in the top upper portion, northern portion, consecutive dry days are positively significant. But consecutive wet days only for the 2 stations in the southwestern portion. Now for the similarly, we are checking for those indices for the station-wise only for the precipitation. We have found in the Bhola it is positive and 95% confidence level, and it is found in the Faridpur and Ishordi, Khepupara, Patuakhali, and also for the Simangol and Sylhet regions. Now, changing in precipitation, changing extreme precipitation indices. For a closer look, we are showing only 2 plots here, one for the consecutive dry days, another for the total precipitation. The trend in a special average time series, left one, it is the showing number of days per year. So what is the information we are getting from here? The average number of the longest consecutive dry days increase at a rate of 1 day per year. And for the precipitation total, it is decreasing at a rate of 11.3 millimeter per year. So in the consecutive dry days, the 95% significant and confidence is there. So overall, one discussion due to lack of the available literature, whatever the literature available, we are just comparing those things with our results. We found that there is a consistent rise in summer days, especially SU 25 and 35 is indicative of potential increases in such health issues. But if in most cases, the victim of these health related impacts are from the most vulnerable lower socio-economic group of the population, as per to a study we have mentioned here. And it is also been noted that consistent increase in tropical nights, warm, it is also warm, tropical nights, warm, it is also to be noted that consistent increases to be tropical night, warm days and warm nights are suggestive of increasing hot weather extremes. An increasing incidence of heat stroke has been reported among rickshaw pullers and low-income generating people in recent years, as per the one study also mentioned here. Some other discussion we can just shortly make, like in the northeastern regions, also we know that flood prone, especially in the pre-monsoon seasons. So we continuously heavy precipitation in the Meghalaya hill tracts and Meghna basins are there. Some study we have mentioned. And an overall increase of consecutive dry days, we already showed, and as well as the decrease of total precipitation also indicate that the country is trending toward a warmer and drier climate. However, an increase of 1 day maximum precipitation has increased the chance of urban flooding and consequent landslides incidents. So what is the home message from our study? First is that the annual temperature has been increased steadily at a rate of about 0.3 degrees Celsius per decade. Trends of the annual maximum and minimum temperature about 0.3 degrees Celsius per decade and 0.4 degrees Celsius per decade respectively. Second is among the all stations, whatever we have studied here, 26, a decreasing trend of summer 35 has been found only 6 stations. I have shown earlier, almost all the stations shows a statistically significant increasing trend for tier 20. The consistent increase in the summer days and tropical nights are also suggestive of increasing hot weather extremes. The average annual precipitation has been decreased at a rate of about 11.3 millimeter per year. However, an increasing trend has been found in the maximum 1 day precipitation, which occurred during the monsoon season. Finally, the average number of longest consecutive days is increasing at a rate of 1 day per year. No significant trend is found in the consecutive wet days for many regions of Bangladesh. Rather indicates that there is a significant trend of warming and change in extreme events in Bangladesh. The current science and analysis of observed records suggested that with the warming of globe, the intensity and frequency of the climatic extremes are also expected to rise in various parts of Bangladesh in future. So what would be the future investigation? In here, in our study, we have only studied temperature and precipitation. Still very many variables are left. So in future, the study could be extreme wind, sunshine hour, mean sea level pressure, relative humidity, and others variables also. So these are the highlights from our study. Observed daily meteorological data used for the ETC CDI indices. Robust analysis and significant estimation are carried out using Senslov and Candletal estimate. Significant warming trend is found, cold nights, warm nights, and count of tropical nights evaluated for 20 and 25 degrees. Significant trend is detected consecutive dry days at a rate of 10 days per decade over the country. So these are the articles, and we are very much grateful for the project fund from the Helix project. And thank you very much. Thank you all.
Thank you, Dr. Das, for your very nice presentation. We'll take the question and answer after all the presentations are over. So I will now invite Dr. S.M. Ahsan Habib to give his presentation on trend of low pressure system over and around Bangladesh. Dr. Ahsan Habib.
Yes, sir. I'm not doctorate. Hello, am I audible?
Yes, yes.
And can you see my screen?
Your presentation is also, yeah. Okay, everything is okay. Go ahead.
Okay, thank you, sir. Good evening, everyone. I am S.M. Ahsan Habib from Bangladesh Space Research and Remote Sensing Organization. The title of my research is Trend of Low Pressure System over and around Bangladesh. First, I want to introduce my study area. In the left image, the shading represents the elevation over sea surface, and inner box represents the area which I used for the detection of the LPS genesis location, means the low pressure system location, and the outer boundary, outer box represents the reference area for LPS tracking. That means the LPS which are genesis within the inner box region and stays within the outer box region that are counted in this research. This study area is dominated by the climate of Indian summer monsoon. In the right image, you can see here, the shading represents the climatological rainfall during monsoon, and the contour indicates the 850 hectopascal level geopotential height, and the vector represents the wind at that level. So we can see here the climatological low pressure area developed over India, and which dragged the moisture laden westerly and southwesterly wind towards the region and causes rainfall. But this is not a regular picture of rainfall during monsoon. It varies within the season. The variation of rainfall within the season is called the interseasonal oscillation of rainfall. In this figure, black bar represents the daily time series of rainfall. You can see here, sometimes rainfall is high and sometimes low. You can see here the two highest peak around June 17 or 1st August. This time, Bangladesh experiences a heavy rainfall. And in both time, the low pressure system is present here. So we can say the low pressure system is a very important phenomenon which causes heavy rainfall over Bangladesh. In generally, low pressure system is a atmospheric cyclonic circulation. The legend of this figure is similar to the climatological figure. We can see here the low pressure system exists over Bangladesh, which causes cyclonic circulation of wind and heavy rainfall. And we know about the impact of this low pressure system. So the trend of low pressure system with the global warming, maybe the low pressure system is also changed the number of days. So this is very important to understand the potential impact of climate change over Bangladesh. Trend of monsoon rainfall over India is shown in this map. We can see within the blue ellipse region, mostly the rainfall is decreasing. But what about the Bangladesh? Another research established that total and weak rainfall in Bangladesh is increasing, but the heavy rainfall is decreasing. So the trend of low pressure system may explain the rainfall trend over Bangladesh. So the objective of my research is to reveal the interannual variation and trend of low pressure system over and around Bangladesh. And I will try to explore the reason behind the interannual variation and trend of LPS. For the detection of LPS, I use the Japanese 55-year reanalysis dataset. And to make a relationship with the SST to the low pressure system, I use the ERA interim dataset. Method for the detection of low pressure system, I use the method developed by the Hatsuzuka et al. 2014. In this method, there are 3 criteria which should be satisfied by any low pressure area to be a LPS candidate. So first criteria is it should be a minimum 850 hectopascal geopotential height. Like in this figure, the inner circle have the geopotential height at the lower level compared to its surroundings area. And that's why it will create a cyclonic circulation. That means the relative vorticity should be greater than 0. And this condition should stay at least 1 day. When these 3 criteria should be satisfied by any low pressure area, then it is detected as a low pressure system by this method. After that, I classified this low pressure system into weak and strong LPS by setting a threshold value for relative vorticity. Below that value is named as weak LPS, and stronger than that value belongs to the strong LPS. I several times use in the following slides the LPS days and no LPS days. That's why I want to clear here. LPS days means the LPS is present within this box region, and no LPS days means the LPS is absent on that day. In the below figures, the central bottom figure, there is a strong LPS is present on that day. Earlier 2 days, there is no low pressure system. So I counted this one as a no LPS day. After that day, this low pressure area get the energy and satisfy the criteria of weak LPS day. Then I counted this as a weak LPS day. And after that, it reaches the strength of strong LPS day, then I count it as a strong LPS day. So in this manner, I counted all the LPSs and no LPS days and LPS days, and also the weak LPS day and strong LPS days. After counting, I perform statistical analysis to make decision. Results. This method successfully detect the low pressure system, and this is the one typical case of LPS. Here LPS is genesis around the northwestern head of the Bay of Bengal, and it propagates northwestward with time. This figure represents the frequency of LPS centers on each grid point each year. We can see here mostly the LPS centers concentrated in two places over central India and northwestern head of the Bay of Bengal. Seasonal variation of LPS days. Among the monsoon days within the study period, around 36% of the days strong LPS is present and 16% days weak LPS is present, and 48% of days LPS is absent. Among the monsoon months, August and September experiences large number of LPS days compared to the June and July. And similar result is also found for the strong and weak LPS days. Among the non-monsoon months, May and October experiences large number of LPS days. It is very interesting that the low pressure system days, number of LPS days is decreasing over time, which may be due to the significant decreasing trend of strong LPS days, because the weak LPS days is not show any significant trend. I wish to make a relationship with the low pressure system and the sea surface temperature. And to do that, first I try to show the anomaly of SST between strong LPS days and no LPS days. It is also interesting that I found the SST is high over the northern hemisphere, but in the southern hemisphere, the SST is low. But exception is around the Arabian Sea and Bay of Bengal and South China Sea. After these findings, I tried to make a correlation with the strong LPS days and the monsoon SST in annual time scale. So I found the SST around the Arabian Sea and the equatorial Indian Ocean and this region make a anti-correlation with the number of strong LPS days. That means the number of LPS days is high over the study area when the SST is low over Arabian Sea and this blue shaded region. But it positively correlate with the SST over the Central Pacific Ocean. As this SST of Arabian Sea and the equatorial Indian Ocean is negatively correlated, so I ran an experiment for the trend of SST, and I found that over the Arabian Sea and the equatorial Indian Ocean, the SST is increasing. That means this increasing trend of SST may be responsible for the decreasing trend of low pressure system. This is a general sketch. When the sea surface temperature is high, then SST make convection over the sea surface or over the sea and cut the moisture to go towards the land. But when the SST is cool, it supply the moisture and wind towards the land and make convection or low pressure system over the land. This is true for Arabian Sea and equatorial Indian Ocean. So I want to make conclusion. Low pressure system is a major rainfall varying phenomenon for Indian subcontinent, and it occupied more than 50% of the days of monsoon season. LPS mostly stay over the central India and over the northwestern head of the Bay of Bengal. Among the monsoon months, the August and September experiences large number of total LPS days compared to June and July. And this is also true for strong and weak LPS days. The number of strong LPS days are decreasing during monsoon seasons in 1958 to 2015. And warming SST of equatorial Indian Ocean weaken the westerly wind and causes the reduction of the number of strong LPS days. Thanks for your attention.
Thank you, Ahsan Habib. At this point, I will invite questions to the presenters. Please.
May I ask a question?
Yes, please.
For Dr. Das about his presentation.
Yes, please.
Hi, how are you doing?
Hello, how are you?
Very good, thank you. I wanted to ask, you showed some trends in various physical quantity, and some of those could be due to natural variability. And I was wondering if people had looked at when is it that the climate change signal might emerge for regions like Bangladesh or around. Was it something which has been done?
Okay, thank you. Very nice concern. You already mentioned the time of emergency of the climate change for Bangladesh. Actually, it was started long before. We can say at least 2 decades before. But especially for the coastal regions, we have found that some coastal islands are very much vulnerable due to the sea level rise and others. And as per the study, what I have showed, it is also very much coincide with the climate projection analysis. So in that sense, emergence already been already there. But government has taken some initiative for some regions, but not for the total regions. So in that sense, emergency is required, and especially natural disasters coincide with this. So that's why it is important. And especially very recently, it is found the San Martin Island, then at the southern point of Bangladesh. It's some parts already been demolished due to 2 causes. One for the sea level rise, another is the human intervention. So both are coincide. So that's why it is important, and in that sense, emergency is there.
Okay. Thank you.
Okay, thank you.
David, are you happy with the answer?
Yeah. I'm just curious if people had done it. I don't know about that locally. So I know that at the global scale, it seems to be in the future, but I don't know locally at all. So happy to learn.
Okay. Any more questions to the presenters?
I have a little question to the second presenter, Dr. Rabiul Awal, about the transport of heat towards south and north. Normally during the monsoon period, he mentioned that the heat is transported southward. Normally it does not happen because during the southwest monsoon season, the winds are mainly southerly and southwesterly. So mainly it is coming from even the southern hemisphere through cross-equatorial process, and the energy is being transported towards north during the southwest monsoon season. But he mentioned that the heat is transported towards south during the monsoon season. I need a little clarification. Am I wrong or it's okay? Thank you.
Rabiul, please.
Okay, so I was talking about cross-equatorial energy transport. So cross-equatorial energy transport is southward net cross-equatorial energy transport. So if you take the vertical integration of all forms of energy in the atmosphere, so I don't know which energy you are talking about. So first I need to know which energy you are talking about. So far I know that as I mentioned that geopotential energy, internal energy, and the latent energy, and the vertical summation of these energies. Then if you calculate the cross-equatorial energy transport from the energy transport, atmospheric heat transport, then you will find that it's actually northward. And lots of studies are there also. And David also have a couple of papers on on this. Yeah.
No. I mentioned that you, perhaps I heard that you mentioned the transport is towards south during the monsoon period. Is it okay or I am wrong?
Well,
Yeah, energy transport is southward. Yeah.
Raviul,
Energy
It
transport is
cannot be.
southward. Yeah.
If you integrate vertically
Yeah.
and if you use the pressure coordinates also, and then you have to get a factor -1/g, then it will become the positive, and it should be positive from south to north during the monsoon period. Whatever it may be the energy, the total energy must be positive. Otherwise, how can the monsoon system sustain?
David,
Okay. I think David is going to answer the
Maybe
question.
just to clarify, the total energy is indeed southward. The latent energy is northward. So is that what you are referring to?
Yeah, this is okay. This is okay.
Yeah, it's because of the conversion of latent heat into geopotential, and then the geopotential energy is larger and southward. So the total is southward.
Yeah.
Raviul,
Yeah.
if you can show the partition it vertically, lower atmosphere and upper atmosphere, then it will be more clear. Because he confused with that, Yeah.
Okay, so I was thinking also like that. Then Andy told me, okay, Andy is my another supervisor, David is my one supervisor. So and he told me that we know this, that in the lower layer it will be northward, in the upper layer it will be southward. So you just need to find out the net transport in which way it's going.
Yes.
Yeah.
It was a very interesting study. And any more questions? Professor Terao?
Thank you very much. So it's very interesting session. And so the first speaker, Saiful-san, told about the IPCC projection, future projection. And so the IPCC have already predicted about, or projected about the future increase in the precipitation in the southern region. So it indicates some intensification of the monsoon system, or it's very difficult. So monsoon circulation may increase or decrease, but the precipitation may increase or decrease. So very difficult. But anyway, so the precipitation increase is projected by the IPCC. And Rabiul Awal-san, so you mentioned about that the decrease in the precipitation in the cross-equatorial autonomous heat transfer increase. So does it indicate that the cross-equatorial autonomous heat transport may decrease in the future or increase? You have any idea about the future projection?
No, I didn't look into the future projection. So maybe after 2 or 3 months later, I would be answered that question. So
yeah, it's very looking forward to your new paper. Yeah, very interesting. Thank you very much.
Yeah.
But you have any idea? Some thinking of how do you thinking about before
okay, so if we think like that, if global warming happens, then the meridional temperature gradient would decrease. So if it decreases, then the transport will be decreased. So something like this, so I can say that in future we might be seeing that there is a decrease.
Yeah, maybe this process may occurring in the future projection. So I am looking for new analysis. Thank you very much.
You are welcome.
Can I respond to Terao-san? Nice to see you.
Hi, thank you.
Yeah. Okay. I like to share a screen again just for one slide. Actually, one of the question was IPCC report shows that precipitation is increasing or decreasing. You can see from there clear trend, but if I maximize, yeah, you can see from there. Sorry, You can see some regions, mean precipitation is increasing, but for some reason with very high global warming 4 degree, the mean precipitation will be decreasing. So there is a regional variation. And in our region, South Asia, we are going to experience more annual precipitation. Even though there is a week of monsoon over the last 2 decades because of mostly aerosol increase, but in the future projection, projected monsoon precipitation, seasonal and also total precipitation over the region will be increasing. So this is one. Second, there was a question of, I heard that Dr. Das was responding about the emergence, whether we have the signal of the emergence. I can refer to a table in the chapter 12 of 6th assessment report, 12.4, over the South Asian region, or the changes that we are going to experience by the end of this century. And you can see there are different regions of the Asia is subdivided, and our region is South Asia, SAS, and here is the South Asia. And in that, all the climatic impact driver, 33 impact driver, you can see they are listed, whether it will be high trend of increasing confidence of increasing, high confidence of increasing, or high confidence of decreasing by blue color, like dry, cold spell will decreasing while mean temperature increasing. And you can see there is also dot in that figure, like South Asia here. You can see a black dot. Black dot means already emerged. So emergence is when the natural variability signal divided by natural variability ratio is more than 1. Some cases is more than 2, some literature shows. So then it's considered as the emerge. So there is a section in this chapter 12, we can find the global emergence, but even region-wise, this report shows which are the climatic impact driver has already emerged. For example, the mean temperature, extreme heat has emerged in all the regions of Asia. This is also you can find in Africa and other regions. For example, in our regions, it's already emerged. But if you see the purple dot, that means by 2050, at least this scenario under RCP 8.5, SSP 5 8.5, there is a medium to high confidence that the cold spells emergence will occur. Similarly, some of them there is no confidence, but when the permafrost thawing, there is already emerged. When the relative sea level rise, that is going to emerge by 2050. And also the ocean acidity going to emerge by 2050. So, and also our atmospheric CO2 emission is already emerged. But due to some literature, lack of literature, some area we have low confidence, direction change, or lack of direction on the emergence. So the emergence information also there. So I stop here. I mean, this is also you can find for every region of the world. So you can even not only the changes which are high confidence, but also you can see the emergence. And the white purple is like thin light purple is from 250 to 2100, it will emerge. The signal to noise ratio will be more than 1. Thank you.
Thank you very
Thank
much.
you. I can still take questions. Fariha?
May I add something on this issue?
Yes, please.
Okay, I want to share my screen. Is it visible?
Yes, yes.
Okay, just I showed you that the low pressure system, the strong low pressure system is decreasing over time. But it is interesting that the rainfall due to this strong LPS is increasing in this region. And you know, the ISO, interseasonal oscillation, during the active days, the rainfall is increasing over this region. So I'm thinking maybe the system is decreasing, but the intensity of rainfall may be increasing. Okay. And also I studied one more research already I published, That one is the southward propagating mesoscale convective system over the South Asia is decreasing, but it causes 40% of the heavy rainy days over Bangladesh, but that system is also decreasing. So I want to say system is decreasing, but the intensity of rainfall due to the system is increasing. So maybe it will published later by Rubiul Islam. But I think
Well,
at this time,
you'll have to explain. No?
Okay, so yeah, I also gone through some other research papers, and those research papers says that the ITCZ will shrink, but at the same time, I mean, it will get narrowed, but the intensity, as he mentioned, that the intensity of precipitation will increase along a narrow band. So maybe because maybe that's why maybe we see that the precipitation is increasing. So it's regional case, or there might be some other dynamics as well. Yeah.
Yes. So is there any question more? More questions? If not, David?
No, I'm good. Thank you. Thank you.
Okay, okay. So thanks all the presenters.
There is a question, I think.
I think there is a question.
Yeah.
Taslima, are you?
Sir,
You want to say something?
Yes, yes, please. Thank you, sir.
Yeah.
Actually, it's question to Rabiul and also to David that you are saying that the ITCZ area is narrowing, but precipitation is increasing. Okay. I would like to mention here that the narrowing is not the cause of increasing precipitation, because precipitation is depending on the deep convection. So if the convection is deep there, whether the area is narrowing or broadening, it doesn't matter. The rainfall will be more.
Okay, so I mean, yeah, so I don't know how to say it. Okay, so the convective area is also defined as, I mean, how do we define ITCZ? So ITCZ, it has lots of definition of ITCZ. So as I told you, that one is the where the maximum precipitation occurs. That's also a definition of ITCZ. And another definition, as you mentioned, that convection. So convection where lots of convection occurs. So that's also the region of ITCZ. And so, I mean, I also said that the convergence of trade winds, that means the trade winds from the southern hemisphere and northern hemisphere meets at some point, common point. So that's where convection occurs. So ultimately, it's the ITCZ.
Okay. Thank you.
Yeah.
Okay. Now the turn comes to the session chair and co-chair. We'll have to summarize the findings of the presentation. The first paper was changes in climate impact drivers over South Asian region based on IPCC assessment report AR6 by Professor Saiful Islam. It was an excellent presentation. He has brought in all aspects of the climate change, global aspects. And those who have not read the report, myself, I also did not read it very, attentively. So this presentation made things very clear that what is going to happen due to climate change in the future. So I'd like to thank him for this presentation. And the next one was by Rabiul Awal on the relationship between atmospheric heat transport and monsoonal precipitation variability. This is a very good topic. And in the Reading University, his professors, I know them, they have selected and they have satisfied us also with this topic. And I think he will do very well. Go ahead. And we would like to see a very good report at the end of your tenure.
Thank you.
And next paper was by Dr. Mohan Kumar Das on climate extremes over Bangladesh, the observed trends. And well, this is also a very good paper, and he has presented indices, climate indices, which shows that the temperature is going to increase, and a lot of indicators are there that the cold nights are going to decrease and warm nights are going to increase, and so on. And the consecutive days of warming is also increasing, but he showed that the rainfall is decreasing. Well, things are okay. He's right, correct, But we'll have to remember the time scale, on what time scale he's studying. During if we take a greater time scale, bigger time scale, then we can overcome the decadal or multi-decadal changes that occurs, oscillations in a larger time scale of 10 years or more. So we know that in the monsoonal system, there are very large fluctuation of 20 to 30 years. Those who work with the monsoonal system, they would know that in the 80s, there were many activities and the rainfall was high. And so when I myself did the analysis in that period, and I did not have the from 1981 to 2020 data set. So I had a very more or less increasing trend of rainfall. But now I am getting, or you also getting, the others are also getting that rainfall is decreasing when we take the initial time at 1980 or 81 and up to the 2020. So during this period, it has decreased. There is no question about it. In Bangladesh, I don't know anywhere else, So this is a good study, Mohan, congratulations for that.
Thank you.
And the last one, trend of low pressure system over and around Bangladesh. So this is a very nice study. And all of us know that the low pressure brings the rain. So things come up here that, well, the number of low pressure systems are decreasing. Again, the rainfall is increasing. So you'll have to explain all these things when you publish the paper. I understand that this is a very good question to solve. Nevertheless, we are observing in this region over Bangladesh, Bay of Bengal, and around surrounding areas of the Bay of Bengal, that the number of disturbances were decreasing up to a certain time, and now it is again increasing. And the intensity of the tropical cyclones are increasing, while the total number of cyclonic systems are more or less same or a little bit in a decreasing trend. So this is because of the warming of the sea surface. Because the sea surface is warming, so latent heat is available for the tropical cyclones which are formed in the Bay of Bengal, and most of them turn into severe cyclonic storm or the category 4, category 5 cyclones. And because of that, the number of depressions are now less in number because they are now all big, all very intensive. That is the reason why we see sometimes the depressions are in decrease. This was a very nice and very stormy session. I should say that there are a lot of questions and answers and exchange of views, and I have enjoyed. So with these words, I will give the floor to our co-chair, Dr. Somarendra Karmaka. Please give your comments.
Thank you, Dr. D. Kadir. Actually, this session is a very nice session, and the first keynote speaker, Professor Saiful Islam, he has presented the nice paper and excellent paper based on the AR6. Practically, we should take into consideration of the impact drivers, how these are changes. And I agree with him that most of the changes are mainly because of the man-made activities. So our activities need to be controlled, and the temperature is increasing. And even in the morning session, I already presented a paper on maximum temperature the country average from temperature over Bangladesh. This has increased by 1.59 degrees Celsius from 1981 to 2016, that is in 36 years. If this is the case, then it is really remarkable, and we should be careful of this. I must thank Professor Islam for his nice presentation. He is a very nice scientist, also important scientist, and I found him time to time in the television to talk about the climate change. So I must thank him very much. The second paper presented by Dr. Rabiul Awal, he is on the relationship between the atmospheric heat transport and monsoonal precipitation variability. Practically, monsoon rainfall depends on the heat transport. So these are interlinked with each other. And so far I heard that he told that the ITCZ has shifted something like that in the southward. In my opinion, I also agree with him, because I found that this ITCZ is shifted a little by about 1 degree towards south. So because of that, practically Bangladesh is getting less rainfall, even India also. But most of the monsoon depressions and low pressure system, which the fourth presenters presented, practically these are, crossing a little bit southward of the main ITCZ or monsoon axis. Now the systems are going through the Odisha coast towards northwest, even it goes up to the northwestern India, especially, Rajasthan, something like that, and causing a flood also. But we are getting, because it is moving, the low pressure systems are moving a little bit southern side of the earlier ones, the rainfall in Bangladesh and surrounding, it is decreasing. And this type of trend has been found by me from 2003, and I must thank Dr. Rabiul for his nice presentation on the heat transport and monsoonal variability. And Dr. Mohan Kumar Das has also.
Sir, I'm not doctor yet.
Okay, but you will be. You will be, no problem. Because David is with you. Okay. So
yeah, David is doctor.
I'm very much hopeful for that. Okay, so Mohan has presented also a paper on climatic action. These are to be also taken into consideration, so that careful about this metal, and proper adaptation can be taken in this respect. And about Habib, SM Habib of Sparso, he has presented a very good paper also. Practically, rainfall is mainly related with the low pressure system. Now, whether it is the low pressure system during the winter season, that is the western disturbances, or it is during the low pressure during the summer season, that means pre-monsoon season, or in the monsoon season, whatever it may be, actually this is very important. All the low pressure systems are giving rain, and he actually distinguished one is strongest or strong based on the vorticity, and one is less strong. And this is very good classification for the low pressure system. And the low pressure system, especially monsoon lows, and also the pre-monsoon and post-monsoon low pressure systems are decreasing, as Dr. Diekade mentioned, because the systems are going to be, intensified into a cyclone. As a whole, the severe cyclone storm has a little increasing tendency, though it is not yet statistically significant. These are happening. So I must thank all the four presenters. What they have presented here, these will be recorded here in the Department of Meteorology, Dhaka University, and I must thank all of them for a nice presentation. Thank you. Thank you very much.
Thank you, sir.
Now let us clap for the presenters.
Yes.
And we conclude the technical session now. Thank you very much, everybody.
Thank you. Thank you. Hello, Tero-san. How are you?
Thank you very much. I'm very fine. So I hope to go into Bangladesh. So
Nice.
maybe
Nice. You are coming? Okay.
Huh?
Let me know when you are coming. Okay.
Yes.
Thank you very much.
Thank you very much.
Visit us.
Saiful-san, so
Yes.
how are you?
I hope to see you to Kuwait as well.
Yes, maybe we have some collaboration about research. Thank you.
Thank you.
Thank you very much.
Thank you to Dr. Diekadir sir and also Shamarendra Karmakar sir for conducting this session, and also all the participants who presented. It was a nice and jovial participation from all of you, and it was a really good session. Now, all of our technical sessions are over, but we are awaiting for our closing session, which would start from 8:30, just about 6 minutes from now. And as you all know, the chief guest for the session would be the Honorable Pro Vice Chancellor of the University of Dhaka, Professor Dr. A.S.M. Maksud Kamal sir. So I invite all of you to stay till the closing session, and which would start in just about a couple of minutes. Thank you all. Thank you again.
Thank you. Oh, excuse me, that is of the record. Professor Saiful Islam, you have gone already?
Oh, no, I'm here. Sorry. Yeah.
I'm very sorry that I have heard about your mother, that she already left this world. So we feel very sorry and very sad. We pray for the peace of her soul, and he must be placed in a very good position in the heaven. So have a nice time, and this is the rule that you have to obey, and you have to agree with this one. So we feel for her, and also let her be in peace. Thank you very much. Thank you.
Thank you, Dr. Kamakar. Yeah, thank you for your nice words. Yeah, and this is part of life. Yeah, we lost her.
This is the part of life. This is the part of life. Mannan aছেন এখনো? Mannan?
Yes, sir. I am here, sir. Sir, Asi, sir.
আছেন না? Kamrul আসে নাই?
He is also there.
He is also here?
Yes, sir.
Okay, very good. Very good.
Assalamu alaikum. Good evening, all. Now we are at the end of our today's conference, International Conference on Meteorology and Climate Science 2021. Our chief guest, Honorable Pro Vice Chancellor, Academic University of Dhaka, ASM Maxkawan sir is already here. And first of all, I would like to request our Honorable Chairman, Department of Meteorology, University of Dhaka, Dean of the Earth and Environmental Science, to deliver his concluding remarks of the conference. Thank you.
Thank you all. Ladies and gentlemen, the Department of Meteorology under Faculty of Earth and Environmental Sciences, University of Dhaka, organizes today's International Conference on Meteorology and Climate Science 2021, that is ICMCS 2021, on 10 to 11 December 2021. BMD, this time BMD is our co-organizer of this event. We are now at the end of this conference. I'm very happy to announce that we have gathered a large familiarity of scientists and academicians for this conference. Almost all the renowned scientists and scholars and faculty members of this field in Bangladesh have participated at this conference. We have participants from different parts of the world too. I'd like to thank all of you for choosing this platform to share your valuable research with us. First of all, I'd like to express my sincere gratitude to Professor Dr. A.S.M. Aksul Kamal, our Honorable Pro Vice Chancellor, the University of Dhaka, for being present as chief guest with us in this closing session. Sir has been a great admirer of this department and has helped a lot in its gradual development. Actually, the department was established under his guidance when he was Dean of this faculty. Thank you, sir. The conference comprises 8 sessions, including closing session, and 60 papers were presented in this conference. Of them, 22 papers were presented from different universities, institutions of the world like Japan, China, Bhutan, USA, UK, and India. Now I'd like to present session summary briefly before you. The first session was on monsoon and tropical meteorology, which has been chaired by Professor A.P. Dimbri from Jawaharlal Nehru University and co-chaired by Dr. Abdul Mannan from BMD. 7 papers were presented in this session on monsoon predictability, monsoon rainfall variability, monsoon precipitation pattern of the Bay of Bengal, and their possible teleconnections with large-scale atmospheric oscillations, tropical cyclone and moisture transport, and so on. One paper was presented on ocean forecasting system using coupled ocean model. All research were conducted considering the climate change issues, as we know that due to global warming, natural disasters are increased globally. Session 2 was chaired by Professor Deepak Aryal from Tribhuvan University and co-chaired by Professor Shahjahan Mondal, IWFM, BUET, and the session was about hydrometeorology. A paper showed soil moisture variations over monsoon zone of India and established that deficit and excess seasonal rainfall clearly influences the distinction of the soil moisture variations for dry and wet extremes. It was a very wonderful presentation, I must say. Other papers dealt with prediction of flood in Bangladesh, which are very important for our country as well. The third session was on agrometeorology, and the session was chaired by Dr. L.S. Rathore, former Director General IMD, and now is representative of WMO, World Meteorological Organization, India, and Dr. Shah Kamal from Department of Agriculture Extension. An important paper was presented in this session on impact of climate change on epidemic outbreak and severity of wheat blast disease in Asia, which is very important to minimize the threat to global food and nutritional security. Another paper showed understanding of future crop water requirements and irrigation demand in the context of climate change, which is essential for long-term water resource management and agriculture planning. The water footprint is a helpful metric for calculating how much water a product or services uses overall. So it was a very interesting paper. A paper on SAU Perilla 1, a new variety of oil seed, was presented in this session. SAU Perilla 1 seed is one of the best edible sources of plant oils rich in essential fatty acids conducive to human health. So the study has many significance, is not only in context of Bangladesh, but also for our subcontinent. A study conducted on 4th April event in Bangladesh was very important too, when huge Boru crop damaged due to an unprecedented thunderstorm. A study on decision support system, DSS, for the marginal farming community of agrarian countries like Bangladesh was also very important. Session 4 was on application and technologies in meteorology, which has been chaired by Professor Toru Terao, Kagwa University, and co-chaired by SM Kamrul Hassan from BMD. A presentation on machine learning framework for the prediction of Bangladesh summer monsoon is a remarkable study in recent development of meteorology. Another paper was on comparison between C-band radar and spaceborne radar. There is a C-band radar in Cherrapunji, Sylhet, so they can use data from that radar. 2 papers were presented from UCAR, University of Colorado for Atmospheric Research, USA, on use of low-cost observation networks to support flood and storm surge inundation monitoring, and impact-based forecasting communication techniques and training based on WMO guideline. Session 5 was chaired by Professor Ishikawa and co-chaired by Mr. A.K. Malik, BMD, and the title of the session was Climate Change and Future Climate Projection. UK Met Office, Headley Center, presented a very important paper on sea level rise and projection for Bangladesh, which enlightened the audience with a complete view of the current climate change and some lights on future projection as well. Another paper was presented on long-term sea level variation and their forcing factors like temperature, solar radiation, etc. A paper was on climate change adaptation related to urban environment was presented by DPRRI, Kyoto University. Session 6 was chaired by Air Vice Marshal Professor Ajit Tyagi, sir, and co-chaired by Professor Nasrin Akhtar Bued on severe weather. The session has papers on lightning, thunderstorms, storm surge, heat wave, and atmospheric methane. A paper on microsecond and sub-microsecond fluctuations in geomagnetic field due to lightning has many significance, and an in-depth study was done to understand very important science of lightning. The speaker showed genesis of tornado in depth. Session 7 was on applications in meteorology, chaired by Professor Tayachi Hayashi and Mr. Mohammad Bozlur Rashid, BMD. Papers were focused on urban heat island, rainfall prediction, which has vast implications in Bangladesh. Another paper was presented on land surface interaction to understand atmospheric heat source over Tibet Plateau. They have a very good research project to observe the heat source of Tibet Plateau. The paper was presented from University of Chinese Academy of Sciences. Closing session was chaired by Professor Dr. Dewan Abdul Qadir and Dr. Shamusher Karmakar from NUAMI. The session has an important talk on changes in climate impact drivers over South Asian region based on IPCC assessment report AR6. Another paper showed the relationship between atmospheric heat transport and monsoonal precipitation variability at different regions of tropical monsoons. Trend of climate extremes in Bangladesh also addressed by one presenter in the closing session. So we can say that in 2 days, this conference covered a wide range of topics on meteorology and climate change and projection. So I think we have learned a lot from speakers in 2 days, and our speakers also received many feedback from our honorable chairs and co-chairs. Thank you all chairs, co-chairs, speakers, authors, and audience for being with us in 2 days International Conference on Meteorology and Climate Science, ICMCS 2021. Last but not the least, we have an announcement that the third ICMCS 2022 will be held on 9 to 10 December 2022. We welcome you all to share your valuable research with us through this conference. Thank you so much. Thank you for being with us in today's.
Thank you, Madam, for summarizing the whole conference. Now I'd like to request Ms. Taslima Imam, Assistant Director, Meteorological, Bangladesh Meteorological Department, to deliver her remarks.
Thank you, Fatima. I'm sorry that my camera is not working properly, so I'm talking behind the camera. Honorable Pro Vice Chancellor, Professor Dr. Maqsood Kamal. Sir, it's very good to see you after a long time, though it is visually. And respected Chairman, Department of Meteorology of Dhaka University, respected renowned scientists and researchers, home and abroad, good evening from Bangladesh. It's a great pleasure for me to attend this international conference on meteorology and climate science 2021. And first of all, I'd like to give thanks to the organizer, the Department of Meteorology of Dhaka University. And I'm happy to also be a part of the co-organizer of Bangladesh Meteorological Department of this 2-day-long insightful research based conference. And at this time, I also give my heartfelt thanks and congratulate to Dr. Professor Tawhid Rashid, because I noticed when I got the opportunity to visit the meteorology department during the inaugural session of this conference, I saw that under her dynamic and competent leadership, the Department of Meteorology has reached in a very new level of excellence. And in the short span of time, obviously, I have to say within 5 years, it is amazing. Thank you very much, madam, for that. You all know that weather and climate have no geographical boundaries and have great influence in our daily life and livelihood. So advancement of collaborative research in the area of meteorology and climate science is very, very important. And this international conference made an excellent platform where scientists and researchers were able to share their research work beyond boundaries. And as I am not wrong, I noticed in the schedule that about 45 research papers have been presented in this conference, which covers a wide range of topics. The main thematic areas were the natural disasters and also the impact of natural disasters in hydro and agrometeorological sectors, climate change, applied meteorology, and application of technology in meteorology. Compared to time, I have to say the number of papers was so many. And due to that reason, the schedule was so tight and interaction was less actually. But this type of conference, people I think love to do more interaction, but we couldn't able to do that because of the time constraint of so many papers here. I would like to pick up some important points from different sessions, and I would like to just share with you, especially the session 1 and 6. I noticed that most of the researcher or the scientists, they work with the focusing improvement and impact of different natural hazards, especially for monsoon depression and thunderstorm using the WRF model. And one thing I noticed that they just say their outputs that this WRF model is for the mesoscale system, but this is also very effective and it is giving a very good predictability of the synoptic scale system too, and which is really interesting to know. And at the same time, I noticed that nowadays the researchers are able to use the high resolution data for mesoscale system analysis and research. And I noticed that they are also actually using the radar and satellite data assimilation with the high resolution data, which are also giving a much more better result for the mesoscale system. And this is very good. I am really pleased to see that, researchers are just synchronizing these all things together to have a very good result. In case of climate change session 5, most of the researchers noticed that the average temperature globally and also the regionally is in an increasing trend. And also the strength of the heat wave and frequency in the Southeast Asian countries is increasing. And a very good paper I actually enjoyed, the wheat blast diseases. And that was a very excellent paper of that session, I have to say, in agrometeorological section. And this threat is actually very vulnerable, and it has a very adverse effect of global food security. And that also the researcher found that is also happening in Bangladesh case, though we are actually most of the wheat we are about his assessment, about his presentation, I came to know that 90% of the wheat we are importing from outside, but still the 10% whatever we are growing here, it is under threat for this heat blast of climate change diseases. And already Madam mentioned the Perilla 1 oil. I didn't know it before, but I came to know this oil from this actually conference, but very happy to know that this oil is very good for health. And our climate is actually favorable for actually growing this type of oil plant. Okay, then another important and very interesting thing I noticed in one paper, but Madam and Nazmul combinedly presented that one, I think. The Bodo rice was dried due to the heat stroke induced by the thunderstorm, and which is a very peculiar case that I have to say that I never seen actually, because most of the cases in normal cases, thunderstorm provide always the cooling effect, isn't it? But in this case, it is very different. I don't know why, but only one single case study was done here. But I think more study should needed for this type of case. And we have to find that actually what type of heat stress is actually impacting on this crop and other things. And also another very important thing I noticed from the session 5 of climate change, that one of the teachers, the professor from the oceanography department of Dhaka University, in his paper that he said that the sea level has increasing trend over North Bay of Bengal, and which is an alarming point, of course, I have to say. And also in another paper with UK Met and Professor Saiful, I noticed that they were talking about the sea level projection is on Bangladesh case is rising more than global average. And another thing, they also mentioned that the positive IOD and El Nino lowered the sea level, and negative IOD and La Nina actually higher the sea level. And this is also very good findings, I have to say. And the session 4, that means in the application of technology, I really got very interested when I came to know about the 3D printer PAWS low-cost observation networking system. And I'm sure that if Bangladesh is able to use this low-cost networking system for observation aspects, that would be very good. And by this time already, Professor Tawhida Rashid mentioned that the presenter, he is coming to Bangladesh, and there's a possibility of coming, and probably he will visit to BMD also, and then we can discuss about this thing, technical issues also. And another important and very interesting paper focus, I would like to focus with you in climate change session, then urban high-rise infrastructural development has a remarkable impact on local wind turbulence. And this is very, very important. As a forecaster, I really enjoyed this paper, and it also increased the wind gust hazard by vertical momentum transport. And this is a very important thing is happening in the city areas. And this is also happening in Dhaka city also. And that's why you will notice that when there is a thunderstorm, you see the severity of air and gust is very severe if you compare it with other times, because the infrastructural development is gradually increasing high and high and high. And so the gust impact also increasing in that way. So this is a very nice paper. I enjoyed in this one. And also in another session, I forgot which session, the researcher talked about the multi-hazard impact-based forecasting system, which is a very important thing as a forecaster, I have to say, and then which is very important and will be very effective if we're able to do it for sector-specific one. Because sector-specific forecast is very much needed for the stakeholders. And if we are able to do that, so it will be a very good outcome from the forecasters or the meteorological department of Bangladesh, I'm sure. So finally, I would like to conclude my remarks here. Again, giving thanks to the Meteorological Department of Dhaka University. And this international conference is a very successful one, I have to say. And I hope that the valuable research outcome of this conference will contribute a lot to further advance research on different fields of meteorology and climate change. And I'm looking forward to the next year ICMCS conference with more success. Thank you very much.
Thank you very much. Thank you for giving the insightful remarks from both. Now, I would like to request our Honorable Chair of the closing ceremony, Honorable Vice Chancellor, Academic, University of Dhaka, Professor Dr. A.S.M. Maksud Kamal sir. So we are very delighted to have you with us. Please say something about our conference and other. Thank you.
Thank you. And thanks to the organizer, particularly Department of Meteorology and Bangladesh Meteorological Department, to organize this conference together, titled International Conference on Meteorology and Climate Science 2021. From the start, the conference has been started. And today, this is the concluding session. And I do see around 48 participants in this concluding remarks. Usually concluding remarks, you won't see so many participants, but this is quite different one, seeing almost 50 participants in the concluding session. This reflects the success of the conference. We came to know the concluding remarks from the chairperson of the Department of Meteorology, Professor Tauhid Rashid, who is happened to be the Dean of the Faculty of Earth and Environmental Sciences. On the other hand, Taslima Islam, who is the Deputy Director, I think, or Director, I am not, maybe she could be promoted now, I don't know. So she, yeah.
Assistant Director, sir, now, and I'm head of the Training Institute now.
I'm a bit advanced because I know you are a good scientist. So from the actually, I say it like this way. So thank you. We came to know the insight of the conference, and you already mentioned the insight of the paper presented in the conference. As I have been noticed that in and around 60 paper has been presented, and 22 papers came from abroad, particularly from Japan, China, Bhutan, USA, UK, and India. And different university from home and abroad, particularly Bangladesh University of Engineering and Technology, Khulna University of Engineering and Technology, Bangladesh Meteorological Department, at the Institute, Bangladesh Air Force, Sher-e-Bangla Agricultural University, Bangladesh Agriculture Research Institute, Institute of Water Modeling, Indian Institute of Tropical Meteorology, Central University of Rajasthan, Royal University of Bhutan, Kyoto University, Kagawa University, Japan, Kosi University, Japan, Columbia University of United States, Comet University, Corporation of Atmospheric Research, Colorado, USA, University of Chinese Academy of Sciences, Ocean University of China, the Pennsylvania State University, USA, University of Reading, United Kingdom, UK Met Office, Headley Center, joined in the conference and provided very valuable talks for the audience. And from my end, I would like to offer my thanks to different universities and organizations attended in the conference and enlightened our students and our colleagues. You know, meteorology is an applied science, and in the changing scenario of the climate, meteorology get further momentum across the globe. And from that viewpoint, University of Dhaka opened the Department of Meteorology back in 2015. At the time, pardon?
2016 July.
2016 July. At the time, I was the Dean of the Faculty of Earth and Environmental Sciences. And we understood the importance of the meteorology, of the atmospheric science, of the establishment of the meteorology department. And from that viewpoint, our university administration took all sort of initiative to open the Department of Meteorology, and World Bank provided huge support to the Meteorology Department to equip the department with all sort of technological support, and all sort of other sort of knowledge support, providing the distinguished scientist of the country to be the part-time teacher of the department. In the conference, I came to know that there were 8 thematic sessions, as mentioned by Tawhid Rashid and Taslim Islam. For example, the monsoon and the tropical meteorology, hydrometeorology, agrometeorology, severe weather, application of technology in meteorology, climate change and future climate projections, and applied meteorology. We understand that in all thematic session, fruitful discussion took place, and active participation also happened in all the technical session. That was a big success. And I do believe the department also came out with some sort of research letter to address this successful conference. And as I understand, COVID-19 will be subsided soon, we do believe, and the next conference will be happening in person. And at the time, our friends who joined in the conference from abroad, we will see them. We will see all of them in at Dhaka, and we will have a very interactive session at that time. So with this couple of words, I would like to conclude my speech, and would like to also conclude the conference. And thank you all to attend in the conference. Thank you to hear me. Again, thanks to the Department of Meteorology and also Bangladesh Department of Meteorology to organize jointly this type of conference, because we would like to have further collaboration and cooperation with the different agencies of the country and university in home and abroad. Thanks.
Thank you very much, sir. Thank you.
Thank you, sir. I feel honored and privileged to get the opportunity to propose a vote of thanks on the closing session of the International Conference on Meteorology and Climate Science 2021. As we have to keep in mind the implications of the COVID situation, we made the event virtually, and on behalf of the organizer, Department of Meteorology, and co-organizer BMD, I would like to thanks to our chief guest from the inaugural session, Dr. MD, our Honorable Vice Chancellor, Dr. MD Akhtaruzaman sir, and special thanks to our honorable special guest, Professor Dr. Nasir Ahmad Madam, former Vice Chancellor of University of Dhaka. And I would also like to thank Professor Dr. Dewan Abdul Qadir, our special guest, who is a very dignified meteorologist. And also our deepest gratitude to the chief guest of the closing session, Honorable Pro Vice Chancellor, academic, our today's guest, Professor Dr. A.S.M. Maksud sir. I owe my sincere gratitude to Professor S. Dash, former professor of Central University of Rajasthan, India, founding convener of SAMA. He was our keynote speaker of the session. We also want to thank our honorable member of the advisory committee from different universities and different dignified organizations from home and abroad, who have graced this event as event successful. I also want to thank our chair and co-chair from 8 technical sessions of this conference. And I owe much gratitude to all the organizing committee members, our students and staff. And I owe much gratitude also to our co-organizer, Mr. Abdul Aziz of BMT Director, Ms. Taslima Imam, Dr. Shamim Hossein Bhuiya, Dr. Abdul Manan for their advice and active participation throughout the conference. Thanks to the colleague Shourab Deshubho, Mr. MD Momin Islam, Mr. Papupal, Golam Rabbani, our consultants, students, and staff for supporting this conference in many ways. Their dedication is highly acknowledged. Last not the least, I would like to thank our chairperson, Professor Dr. Tawhida Rashid, and she guides us in all ways. And finally, thanks to all distinguished participants, all the honorable delegates who delighted us with their presence and made the program successful. Thank you.
Thank you. Good night. So,
Thank you. Good night.
Okay, thank you, everybody. Goodbye.
Thank you, everyone. Thank you, everyone.
maybe take a picture, please. I will request everyone to stay connected. Okay. Shubho, please.
An opportunity.
Yeah.
We don't want to miss that one.
Okay.
Possible.
Okay.
Give us just a few minutes to arrange everything.
পোজ দিয়ে তো কখন থেকে বসে আছি।
Just a few minutes more, sir.
I think Saurabh must get a special thanks from me because I noticed that he and his team, how nicely actually arranged this conference, visual conference. Thank you, Saurabh.
Thank you, madam. Sorry, I can't say much at the moment. There is some echo issues. Thank you, everyone. I think we have taken the virtual snap. Hopefully, I will send them actually to you, and see you there.
Please, 2 minutes. Please, there are 2 minutes.
What's happening, guys?
Echo, sir, echo.
So is it okay?
One more, actually.
Okay.
Just give us 2 minutes. Thank you, everyone, again for joining us at this event. And as you know, the next event is 9th and 10th of December 2022. So it's less than 1 year. We hope to see you there.
Okay, thank you very much. Thanks, everybody. Bye.
Okay, thank you, everybody. Bye-bye.
Okay, bye-bye. Thank you.
Thank you. Bye-bye, everybody.
Bye-bye.
Thank you very much.
Yeah. You will stay well. Bye-bye.
Thank you, ma'am. Assalamu alaikum, ma'am. ম্যাডামের সাথে তো পরিচয় হয় না। হ্যাঁ দেখেছি, জি পার্সোনালি কথা হয় নাই কোনোদিন। জি
আমাদের আরো 2 জন কলিগ জয়েন করেছে।
হাই, ওয়ালাইকুম সালাম।
তাড়াতাড়ি ফিরে আসো শেষ করে। ডেভিড তো আসবে 14 তারিখ।
ডেভিড তো এখন ঢাকায় আছে। জি
ওকে, বাই, গুড নাইট।
ওকে, ঠিক আছে ম্যাম, আল্লাহ হাফেজ।
স্বামীর সাথে কি যোগাযোগ হয় নাকি? ওরা একই ক্যাম্পাসে?
একই ক্যাম্পাসে, আসলে উনি একটু দূরে থাকে, আমি একটু দূরে থাকি আর কি।